Okay, good morning to all. Today we say about the topic is case study on flywheel failure. Okay, first what is flywheel? Flywheel is a one of the machining element. Flywheel is the one of the machining element which is mainly used to store the rotational energy, which is mainly used to store the rotational energy and also convert the kinetic energy. Okay, and also convert the kinetic energy. So its main application is store the rotational energy. Okay, it's mainly used in engine applications and also automobiles. It's mainly used in engine applications and also automobiles. Okay, so in this flywheel failure we have considered three topics or three parts. Okay, first one is the parts of the flywheel. First we see parts of the flywheel, and second we see material. Okay, material of the flywheel, because the material is very important for design purpose. If you have focus on material, means the good material, you select the good material. Otherwise lack of material means definitely the failure will occur. Okay, and also third one is a important one, the forces or stresses acting on the flywheel. The forces or stresses acting on the flywheel. Okay, so in this part, in this flywheel, mainly the first part is the flywheel part, that is the rotational part. The flywheel part, that is the rotational part. Okay, the second part is the gearbox, and the third one is the shaft, and the fourth part is a battery. Okay, so the first one is a flywheel, that is a rotation part. You see the diagram, you see the video. So that is the rotational part, and the second one is the gearbox. Gearbox is the is directly connect with through shaft, and the next part is a battery. Battery also is directly connected to the connecting elements. Okay, so mainly the subordinate elements is three parts, that is the shaft, gearbox, battery. Okay, that is the main element is a rotating part. So in this rotating part is a important part. So in this part the stores the energy, that is the which energy? Rotational energy. Rotational energy is the stored. Okay, rotational energy will be stored. Okay, so this is a important one. This is a parts of the flywheel. Okay, so the second part is the materials. The second part is a material. So in this flywheel material, mainly the iron material is first material is the iron material, the second material is the steel or aluminum, and the third material is the high strength steel. Okay, so mainly industry point of views, many of industries selected the high strength of steel. High strength of steel, because the strength is very important. So the strength is a or limited tensile strength. That is one is a major disadvantage in flywheel, that is the limited tensile strength allowable only. Okay, that is the major disadvantages of the flywheel. So in industry point of views, we have select the high strength of steel. Otherwise mainly it is made of material is iron material or steel material or aluminum material. Iron material or steel material or aluminum material. So these are the materials are mainly used in the flywheel materials. These are the materials are mainly used in flywheel materials. Okay, mainly this is used in the energy storage, that is a braking system. This is mainly application is automobile application. So in this automobile applications we have deeply concentrated on breakage system or energy storage or braking systems. Okay, so these are the material considerations about the flywheel. If you lack of material focus point, material strength, means definitely the flywheel failure will occur. Okay, so first you concentrate on in this design process. You have designed the flywheel, means first you have first point is the parts of the flywheel part, which are the parts are included in the design product. That is also first point. The second point is the material, because the material is having a strength. Okay, and the third part is the which are the stresses are acting on the flywheel, which are the forces are acting on this flywheel. So in this flywheel means mainly you have considered the torque. Torque is the rotating element. Torque node unit is a Newton meter. That is the or a certain length. For example, this is here on rod means you have some rotating through length. The force is acting on through length means a Newton into meter. So meter is the length of the rod. The force is acting on the rod. Okay, this is a rotating or moment, rotating or force of the. Okay, so this is a torque is the unit is a Newton meter. So the first you have considered the point is a torque point is one of the important point. Okay, next moment of inertia. Next we have concentrate on moment of inertia. Okay, first you have concentrate torque, the second point is moment of inertia, and then tensile force, rotating force. Okay, so you have select the material. Main the design purpose is first moment of inertia, second torque, and tensile force or rotating force. So you have considered the four forces. You have considered the four forces. You select the material considerations, because so that is the material consideration. I selected the material high strength steel. That is it is mainly compared than normal steel and aluminum materials. So normal aluminum and normal steel materials means compared than high strength steel is a it's having high strength, and also it's having the high carbon content also. So carbon is directly proportional to the hardness, so the hardness material is also high. Okay, so to increase the strength and to increase the hardness means definitely you avoid, you eliminate the failure. Okay, you eliminate the failure in the flywheel part, otherwise you cannot eliminate the failure. Okay, so its mainly application is the